Hello, this is Mr. Weideman, Lafayette High School pre-calculus class. Our properties of logarithms chapter, section 4.5 in your textbook, using our log properties. This is one of the most important log properties we have, where we take this exponent, this guy right up here, and we put him in front, and he becomes a coefficient. We call this the power rule. Now, one thing I want you to get straight is M and P can be entire polynomials. They don't have to be just numbers. All right? This M, which we're making a base, can be an entire polynomial, just so long as it's a positive and real thing. And same with P. And it can actually be a negative thing. It just has to be real. All right, so let's put this into practice. And we did some of these in class today. All right, so what do? That 2, which is an exponent, comes down in a coefficient. Let's try this one. The 4 comes down as it was an exponent, now it's a coefficient. Now let's take a look at this one. What's its exponent? X to the 1/2. Which is the same thing as square root of x. The exponent comes down as a coefficient. What happens here? Same drill. Now, when we get to this point, that one can do a little bit more work. And we're going to get to that in a minute. What do we do with this guy? The 9 comes down as a coefficient. What about this guy? That is x to the 1/3 power. That comes down as a coefficient. Okay. And then we have another guy here. And the 2 comes down as a coefficient. And then I've got a few little things that I want you to be aware of. Oftentimes, let's take a look at this bottom one. See that 2 log x plus 4. There is a tendency to try to distribute the log into, distribute the 2 into the log x plus 4. That can't be done. Just think if the 2 was outside a radical, all right, just for giggles. What if we had 2 outside square root of x plus 4? I can't distribute. The 2 can't go in there. Because the square root is an operator, just like log is an operator. So I can't distribute into an operator. All right, so if you think that you can do something like this, when you can break it apart, okay, by distributing the 2 that way, that's a big no-no. Cannot be done. All right, so that's a very common mistake. Beware of that. Okay, now let's look back at this little problem right back up here. Okay, we use the power rule, but you may have noticed I've got a multiplication, so I can use my multiplication or my product rule. Now can I distribute the 5? Yes, you can. All right, need to very much look at the difference. Can I take the 5 and multiply it to the 4 and then use my multiplication rule? No. But I can use my multiplication rule, and then I have a 5 out here that can be distributed. All right? So it's a subtle difference, but it's huge. Okay? So be very careful and very aware of that when you do your homework. Okay. Now, what we do is another property I want to talk about today, and we've talked about this before. We're just going to expand on this, and this is the inverse property between logarithmic and exponential functions. And it's a very powerful tool for evaluating expressions and actually getting values without a calculator. And that's what we're going to concentrate on today. All right, now I have log base b, and then I have b raised to an exponent. Okay, that is this guy right up here. This guy right here, I call him an exponent, but he can be an entire polynomial if you want. Here I specifically use the word expression. It could be one single constant. It could be any real number. It could be a polynomial. But anyways, this method allows me to evaluate these expressions using this inverse property for evaluating this with that expression. And how does it do that? It does that because these guys are inverse operators. So they undo or kind of cancel each other out. Right? So as long as this guy and this guy are the same, as long as this guy and this guy are the same, then this particular property will work. All right. Let us try some. Okay, so let's take a look. These are the evens of your homework assignment, and sometimes these are ridiculously simple. Bases match. So what does our property tell me? The answer is just simply the exponent. Let's try another one. Bases match. Remember, natural log is the same thing as log base e. So that means this guy and this guy match. So what happens by our property? It just becomes the exponent. Or you could write 2 to the 1/2 power. It's the same thing. These guys and these guys are inverses. Just simply equals 8. Let's try another one. Okay, now it's getting a little bit complicated. All right, I want you to think, are these exponential functions? Yeah, they are. There's base 9 raised to the 1, base 4 raised to the 1. Now we've got a problem. These guys don't match. So I can't use my inverse property. So what do? Well, the first thing that I do is I recognize, hey, this is my multiplication property that I use to expand. Let's use my multiplication property to condense 9 times 4. Okay, let's back this up a little bit and talk. Well, I can talk about this a little bit right now. Okay, the 9 times 4 gives me the 36. So I've got a log base 6, 36. Well, 36 is simply 6 squared. Now my bases match. Now I get my answer of 2. Kind of clever. So I'm using my multiplication property first, okay, because this expression, okay, if I was to take the 36, I could do my multiplication property and break it up into that. I'm just doing it backwards. All right, now what about this guy? Well, it's kind of a spin-off of number 14, except we're using our division property. 16 divided by 2, log base 8, 8 to the 1 power, so that's simply just 1. That's pretty easy. Now it gets really tough. Now it starts getting really hard. Okay, now what I'm going to do here on this one is I got 2 things multiplied. What I'm going to do is I'm going to use the reverse of my power rule. I'm going to treat this term like a coefficient. Use my reverse of my power rule and make it an exponent. And that's going to be my first move. Let's do that. Okay. Now what am I going to do? I don't have anything that matches. Nothing looks really good, except there is a possibility here. This guy and this guy. This is an exponential raised to a log. If I could get bases to match here, I might be onto something. So let's do that. So let's turn that into a 3 squared. Now I've got this. Okay, so, I'm a step ahead. Now what I'm going to do is I'm going to take this 2 and I'm going to distribute it. Let's see what that looks like. Okay, good. Now, what about that 2? Kind of in the way. Well, let's use my reverse of my power rule again. And let's take that and let's make it an exponent on the 8. Let's see what that looks like. Now I'm getting somewhere. What happened here? Well, this guy and this guy are inverses. So that's how these two things go away, and I get log base 8, 8 squared. Well, this guy and this guy are inverses, logarithmic of an exponential function with the same base. And then that's how I end up with the 2. Okay, we're going to do one more, then I'm going to end this video. I've got one more video that I want to do. Okay, I'm going to do another hard one. Okay, what's going on here? All right, well, let's just take a look at this exponent only, just this guy. All right, and what I can do is I can use my multiplication property in reverse. So let's do that. So that's the same thing as log base 5, 6 times 7. So I'm using my multiplication property. All right, so 6 times 7 is 42. All right, so not bad. And then what have I got going here? I've got 2 bases that match, these guys. So my answer just simply becomes 42. All right. So what's the trick on these? The trick on these is the inverse property, our power rule backwards and forwards. And remember that our multiplication and division problems can be used to condense things as well as expand things. Okay, I'm going to have to stop this video right here. It's getting pretty long. And then I'm going to show you some more properties and show you how to use those to expand. And then I'm going to get to what the homework assignment is. All right, so meet me on the next video.